Before we go any further, we have to discuss something called access qualifiers, and these are applied to classes, fields, methods, and interfaces. Now there's four types. Public, which means that whatever you qualified can be accessed from any class in any package. Protected means that it can be accessed from subclasses and classes in the same package. The default, which is not specify anything, means that it can be accessed from any class in the same package. And private means it can be accessed only from within the current class. And here I've illustrated the hierarchy. And the thing to notice is that protected can be accessed more widely than the default none. Right then, member classes and interfaces within an enclosing class can be labelled private or protected. Now we haven't actually discussed what these are, okay? But basically you can put a class declaration within another class or interface, just like you can put method declarations in. And this can be quite useful if you don't overdo it. And I'm going to cover all these and the subject of what's called nested classes in a future lecture. So for the moment, I'm just going to stick with what are called top level classes, which is what we've seen so far. Top level is the opposite of nested. So since this doesn't apply to top level classes, we can ignore that for the moment. Top level classes and interfaces, and that's the only sort we've seen so far, can be either public or default if you don't specify anything. They cannot be protected and they cannot be private. Okay, so this is an example to illustrate that. It's in two files and in two packages, package 1, package 2. This first class is abstract, doesn't have to be, but I have to label it as abstract just to show it doesn't really make any difference. And this is a public class B that extends it. Here in package 2 we've got class C that extends something. Now if that something happens to be 1.a, then you'll get a compiler error because you haven't got any access from this package. And if it happens to be 1.b, then it's okay. And similarly, if we specify a field in here which is of type 1.a, that will give a compiler error. And 1.b is okay. And you get exactly the same sort of behavior if we had interfaces here instead of classes. Same sort of thing. You must have access to a class if you want to extend it, or create an instance of it, or access methods and variables within the class. And if you can't access the class, then it doesn't really matter what sort of access rights the methods, constructors and fields within the class have. You won't be able to get at any of them. And at least not directly. You can kind of indirectly access via overriding. It will allow you to access some methods which would otherwise not be allowed via a public superclass. And I'll show you an example of that later. But it's not really a shock when you see it. It does just what you think. So it does the right sort of thing, so you don't really have to worry about that. The ability to access an entity is something which is determined by the compiler at compile time. It's not something that's worked out at runtime. And that's something to bear in mind if you're trying to work out whether you can access something or not. Now, if you override or hide a method in a subclass, then the overriding or hiding method must have the same or wider access qualifier. And normally you keep it the same. So the question is, why is that? Well, a subclass object must be usable in any place where you can require a superclass object. Okay, that's a basic principle. You've got a parameter of some type T, then you can pass in any subclass of T. A basic principle of object-oriented programming, because of course it is a class. Now, if the access qualifier was more restrictive, some code would work okay with the superclass but not with the subclass. And here's an example to illustrate that. We've got class A here with a method in it, and class B that extends it and overrides it. And the method here is default. Of course, that will give a compiler error because it should be public. And if that was okay, which it isn't, then you might have something like this. Here's a class C with a method in it. It takes a parameter of type A. So into that method you could pass an object of class B or one of class A. That would be equally acceptable by the basic principle of object-oriented programming. So what happens down here when we attempt to call M1? Well, straight away we've got a problem, because if you're passing in an object of class B, then of course it's going to look at that object and see that B has been, the method M1's been overridden in B, so we'll attempt to call that. But that of course is going to bypass the fact that B is not public. It is default. So if C was in a different package, it should not be permitted access to that method M1. So this is where you get a problem, and that is why you're not allowed to narrow the access. Okay? If you take a really extreme case, for instance, where it was private, you shouldn't be able to get at it at all. Okay, so that's why. In general, an overriding or hiding method must not be more restrictive. And normally, you just keep the access the same. And interfaces, by the way, the methods in them are implicitly public. You don't have to put public in. You can if you want to, but you can't put anything else in. You can't declare them private or anything, or protected. They are public, and that's it. And any fields in them, by the way, are public as well. Public, static, and final.